Welcome back to my video series about how to build a sub 250 gram 3-inch freestyle drone for absolute beginners who have never built a drone before. This is a video series, so if this is the video you were looking for, then great. But if you just stumbled across this video, then feel free to watch it. But if it feels like you're coming in the middle, that's why. There is a playlist linked in the video description below that has all the videos in this series. And if you're not sure what the heck's going on here, then you should go back to video number 1 and hopefully it'll all make sense. A whole bunch of the content in the video that you're about to watch is borrowed from my previous build series where I built a 5-inch drone. I just couldn't bear to re-record hours and hours of content that was going to be exactly the same, except instead of me holding a 5-inch drone in my hand, I'd be holding a 3-inch drone. I'm going back through these videos, and anytime there is a content that is unique to the 3-inch drone that you're building right now, I'm going to record that and I'm going to edit it in. But if there's a whole bunch of this video where I'm talking and I'm holding a 5-inch drone instead of a 3-inch, don't let it confuse you. It still applies to what you're doing. This video is going to be about setting up the analog FPV system. If you're using DJI, Walksnail, or HD-Zero as your video system, then you can still watch the video, but the content in here isn't going to directly pertain to you. And the first thing we're going to do is get these components. They come in a foil bag like this. And this here is our video transmitter. It's going to take the signal from the camera and transmit it over the air over an antenna. It comes with these mounting screws, and these mounting screws are not going to be used with our frame, so you can keep those as spares or do whatever you need to do, but we're not going to be using those. This cable here is referred to as a pigtail cable. It's called that because it's kind of short and a lot of times it's curled up like a pig's tail is stereotypically pigtail cable. And it is used to connect the video transmitter to the transmitter antenna. You see there's no antenna here. It's worth memorizing the names of the connectors that are used. There are 3 common connectors that are used in FPV for RF connections. And 2 of them we have here. This one here is an MMCX connector, MMCX, that's worth memorizing. And here's the other side. Don't plug this in right now, we'll plug it in later, but it'll plug in like so. And MMCX connector is sort of the middle-sized one. The big-sized one we have here, this is an SMA connector. And SMA connectors are larger and more robust, and so a lot of times you'll have an antenna with an SMA connector, but the video transmitter won't want to put a great big honking SMA connector on it, and so you'll use a pigtail to get from the smaller MMCX connector to the SMA connector. We're actually not going to use this because we actually have an antenna right here with an MMCX connector right on it, and that's what we're going to be working with. So save this. This is definitely worth saving. You'll come across it, a need to use it some other time. But what I want you to do right now is take your video transmitter, and I want you to see that these ears right here are scored. And what we're going to do is we're going to break those off. These are mounting holes, but we're not actually going to be mounting this video transmitter with these holes. So I'm just going to get, this is a forceps, and I'm just going to sort of grip it here and carefully break it off. Yep. You can probably do it with your hand if you don't have a tool, but I like to find a tool that's more precise. So we'll break those off and we'll throw those away. Now let's look at these labels on the video transmitter and understand what each of these different pads is doing. Each of these pads is going to be soldered to a wire. Well, some of them we're not going to use, but every analog video transmitter will have these same pads pretty much. And if you want to work with analog video transmitters, you want to understand the purpose of them. So you're not just like looking at a wiring diagram and sort of without understanding why you're doing what you're doing, following the wiring diagram. You won't even need a wiring diagram if you understand what these pads are and how they're used. So the first 2 we're going to look at are labeled ground. Ground is the ground wire. Every piece of electronics needs a ground wire. Say no more. VBAT, and that is the term for battery voltage, VBAT, battery voltage. And that means whatever voltage the battery that you're using to power your quadcopter from. Well, what voltage is that? Because we need to know that every device has a rated input voltage range. They'll say this is rated for between 7 and 26 volts. And what that means is that if you give it less than 7 volts, it won't turn on. And if you give it more than 26 volts, it will probably fry. So you need to be within that voltage range. In this case, VBAT is almost certainly referring to the voltage range of a 2S LiPo, which gets down to 6 volts at the minimum, up to a 6S LiPo, which gets up to about 25, 26 volts at maximum. But we would want to verify that by looking at the specs page for the video transmitter or whatever we're working with, because VBAT by itself doesn't guarantee 2S to 6S, although usually that's what that'll mean. A lot of other times we'll find that the voltage range is actually marked on the device, but we always want to know what the voltage range is for a device before we solder it up, because it has to get a voltage that's in that range. Oh, right, we can't forget to check the input voltage for the video transmitter. So here I've got the product page for the video transmitter pulled up, and we're just going to look at the specs, and we should be able to find somewhere, there we go, it should be here-ish, input voltage, 7 to 36 volts DC in. So that's even more than 6S voltage. 6S is 25 volts. It can go even higher. So our 10 volt regulator is going to be fine. It's within that range. The next label is SA, and that stands for SmartAudio. And this is a really confusingly named thing that is challenging to explain. I'm going to do my best. The first thing you need to know is that SmartAudio has nothing to do with audio. People think that it has to do with, well, this is a video transmitter. Maybe it's also transmitting audio that I can hear in like an earpiece that I wear. It isn't. This video transmitter, pretty sure. Oh, no, it does. It isn't. It isn't. In fact, right next to SmartAudio is audio. And that, in fact, would be where you would put a microphone if you had a microphone on the drone, which we don't and we're not going to. But if you put a microphone on the drone and wired it to the audio pad on this video transmitter, it would transmit audio back to your goggles, and you could plug an earpiece into your goggles and put it in your ear and hear the rushing of the wind usually, but sometimes you can hear the motors, and some people like that. It's not very commonly done. Getting back to the SmartAudio pad though, what does that do? Video transmitters can be on a certain frequency, and that frequency is referred to as a band and a channel. We'll have a band and a channel, and those two things together tell us what frequency the video transmitter is on. And we need to know that because if two pilots are on very close frequencies, they'll interfere with each other, and then won't be able to fly, and one of them will lose video and crash, and everybody will be angry. One of the things you have to do when you fly with other people is manage the frequency that you're on, so you don't interfere with them. Or you could be standing next to a Wi-Fi access point, and that Wi-Fi access point could be transmitting and interfering with your video. And if you go to a different frequency, a different band and channel, then you could get away from it. So knowing what frequency, what band and channel you're on is important. And then you also have output power. Your output power could be set very high to maximize your range. But again, if you're flying with other people, especially at a race, they'll have you turn your output power down because that reduces interference and lets you get more pilots in the air without interference. The takeaway is that you need to change your band, channel, and output power semi-regularly when you're flying. And if you look, you can see right here, there are buttons right here. There are buttons, frequency, and power. And by pressing these buttons, you can change the band and channel and power of the video transmitter. But that's a pain in the butt. Nobody wants to do that. Nobody wants to get in there and like long press, short press, short press, short press, long press, short press, looking at the LEDs, trying to remember 5 blinks means I'm on race band and 6 blinks means I don't do any of that stuff. Because the flight controller can control the band, channel, and power of the video transmitter. The flight controller can show you a menu in your goggles, no button pressing, and you will take your controller and you will go dunk, 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 dunk. I'll show you how in another video. And you'll change the band, channel, and power with a menu in your goggles instead of by pushing buttons. And that's a much nicer way of doing it. And what makes that possible? How does the flight controller say to the video transmitter, yo, video transmitter, please go to this band channel. Please change your power. It's with the SmartAudio wire. That's what that is. SmartAudio lets the video transmitter talk to the flight controller so the flight controller can say, I want you to change your band, channel, and power. And that's like super important. The video wire carries the video signal from the camera. And then we've got these two, 5 volt out and ground. And what that is there is a 5 volt voltage regulator on the video transmitter that will output 5 volts to power a camera. And that we're not going to use that because our flight controller also has voltage regulators to power the camera, and it is convenient to have all of your peripherals be powered from the flight controller. All your wiring goes back to the flight controller. Just keeps everything sort of neat and logical. But if we had a car, let's say we had an RC car, and we were going to put an FPV system on an RC car. Well, an RC car doesn't have a flight controller. So how would we power the camera? Well, one way to do it would be to use the 5-volt regulator on the video transmitter, and that's what that 5-volt out and ground are. They are for if you are going to power a camera directly from the video transmitter because you don't have a flight controller, but we're not going to do that. So we will not be using the 5-volt out and ground wire at all. We will not be using the audio wire because we don't have a microphone, but we will be using ground, VBAT, SmartAudio, and the video wires. And the next thing we're going to do is we're going to solder some wires to them. Now, I have got, you can't see it off camera, I have got a bunch of spools of wire. And that's what I'm going to be working with because they're colored. You could also theoretically, if you just have collected up a bunch of spare wire that you have used over the years, you could use that. Also, your flight controller comes with a bag of wires. Here's why I don't like this. You can use this in a pinch, but the reason I don't like it is they're all black. And without color, it's easy, like the electricity doesn't care what color the wire is, but it's easy for you to make a mistake and accidentally solder the battery voltage wire to the video pad. And if you put specifically VBAT, if you put the VBAT wire in the wrong place, you'll fry the video transmitter. It'll just be dead. So I would rather you use colored wires. It needs to be silicon insulated wire. If you have like some kind of wire that you got from the automotive store, don't use that. It should be fine strand silicone insulation. Silicone is a nice soft insulation. You can pinch it with your fingers and easily separate it, as you see I did there. It needs to be fine-stranded wire. I'll put a link in the video description to the wire assortment that I use. It's no problem. If you have to, you can use this wire. Just don't screw up the wiring and put the wires in the wrong place. Okay? I've finished soldering up the wires, and I want to show you the colors that I've used so you can track them as I then go forward with soldering to the flight controller, but also just so we explain some of the conventions that are used. And one of the most common conventions, you probably already know this, is that black is ground and red is the supply voltage, in this case battery voltage, but whatever the supply voltage for your peripheral is going to be, it's going to be the black and the red wire. And that's really important you stick with that. Again, the electricity doesn't care what color the wire is, but if you use a red wire for something other than supply voltage, somebody's going to solder it to VBAT eventually and fry the thing, maybe you. Then we have SmartAudio. There is no convention for SmartAudio. I've used a green wire. And then there's video, and video is almost always a yellow wire. So we'll stick to that convention for convenience. As far as the flight controller wiring goes, I've pulled up this wiring diagram because the labels on the flight controller itself are extremely small and hard to read. And unfortunately, the user manual for this flight controller doesn't have any wiring diagrams like that actually show you how to wire things up. They just show you the pad labels, but that's what you've got me for. And I'm going to show you how to know where to put the wires so you don't need a wiring diagram. Right? Yeah. So if we look over here in this corner of the flight controller, there is a cam pad, and that is going to be the video signal coming from the camera, which we haven't got to yet. And then right here is a VTX pad. And it's a little ambiguous because I know of at least one flight controller that labels the video transmitter power as VTX. And we wouldn't want to mess that up because the power is going to be VBAT, battery voltage. And again, if we put battery voltage in the wrong place, we'll fry the video transmitter. But if we look here, right next to VTX is 10 volt. 10 volt. 10 volts is the kind of voltage that a video transmitter would want. Typically, it's going to be VBAT, which is going to be between 7 and 26 volts. 10 volts is between 7 and 26 volts. It's very common to give a video transmitter 9, 10, maybe 12 volts. It's better to run the video transmitter off a regulated voltage instead of off of battery voltage directly because the regulator cleans up the power a little bit. There's less voltage spikes, and you'll generally get better results from the video transmitter running it off a regulator. So here we can infer we've got ground, 10 volts. That's going to go to the VBAT pad, We'll verify the voltage input range of the video transmitter in just a second, but I think 10 volts is going to be fine. VTX, that's going to be the video going to the video transmitter. And then we've got SmartAudio. And what you need to know is that SmartAudio goes to a UART TX pad. What's a UART? It's time to learn what's a UART. A UART, first of all, UART, U-A-R-T, stands for something. No one ever says it out loud. I'm not even sure I could probably figure it out. Doesn't matter. UART, U-A-R-T. And what it is a way to connect a peripheral device to a flight controller. Kind of like if you have a computer and you plug in a mouse or something to a keyboard to the USB port. It's kind of like a USB port, except way, way dumber than a USB port. A UART consists of a TX and an RX pad. TX is transmit, RX is receive. A UART is bidirectional communication, and you have a TX and an RX pad, and that's how you do bidirectional communication. Video transmitter, SmartAudio, is one of the things that can go on a UART. We're going to hook our receiver up to a UART. If we had a GPS device, a GPS receiver on a quad, which we don't, but if we did, it would hook up to a UART. That's the kind of thing that hooks up to a UART. UARTs don't carry video or audio. They carry digital data, digital communication, and SmartAudio is one example of that. However, what makes SmartAudio a little bit weird is that we are only going to use the TX pad. I said use TX and RX, but when we'll see that when we get to the receiver, we'll wire that up with TX and RX. But SmartAudio is an example of a protocol that only uses the TX pad. And you might think, well, does that mean we're only transmitting data one way, but not back the other way? But it doesn't. And here's where it gets like way more complicated than it needs to be. It turns out the TX pad can also do bidirectional communication, basically just by taking turns. Whereas if you have both the TX and the RX pad, you can transmit both directions at the same time, and it's faster. But SmartAudio doesn't need to be that fast, so it only uses the TX pad. So take away from this, UART connects a peripheral to the flight controller. SmartAudio is one of those peripherals. Usually, a UART will use a TX and an RX pad, but in the case of SmartAudio, we only use a TX pad. And in this case, this TX pad conveniently placed right next to the video transmitter wire and the 10 volt and ground pad that are just perfect for powering a video transmitter. These pads are made to work for the video transmitter. That's why they're there. It's really hard to solder without being able to actually get my face close and see what I'm doing, because I'm doing it on camera. Makes me look like I'm much worse at soldering than I actually am. Hold on, I can't do this. Next, I'm going to solder the wires of the video transmitter to the flight controller, but don't just like solder them down. Let's make sure the wires are the right length, and let's think carefully about how to route the wires. So the video transmitter is going to mount here in the back of the quadcopter. We don't want it to mount sideways because if you can see, it'll hang out over the edge of the carbon fiber, and that will increase the chances it'll get damaged. So it's going to go like this roughly. Yep, that's good. And then another thing we don't want is we don't want the wires to go over the top of the flight controller if we can avoid it. And the reason for that is that the battery straps that hold the battery to the top plate are going to be passing through there, and it can be easy to sort of snag the wires or pass the battery strap under the wires and yank the wires. So in order to sort of keep the wires neat, we're going to pass the wires underneath the flight controller. So the wires are going to kind of go like this. They're going to go under the flight controller, and then they're going to come up and around and fold back. And what I'm going to do is just roughly measure out about how long those wires need to be. Give myself a little bit of extra slack, like that much maybe. Yeah. And I'm going to cut them off at that length. If you're not sure, leave them a little long rather than a little short, because you can always cut them shorter, but you can't cut them longer. You have to resolder them. And then I'm going to pass the wires under the flight controller, and I've just realized a problem. If you are using the all black wires that were included in the kit, if you pass them under the flight controller, you're going to lose track of which wire is which. So you might rather solder them like this. And then can we just lift this up and pass the whole video transmitter through? Maybe. Let's try that. Let's try that. I would just pass the wires underneath and solder them based on their color, but that may not be an option. Okay, so here the wires are soldered in the correct place. You can double check that yours are exactly the same as mine. And then I'm going to lift this up. I might could have done it if I hadn't put these zip ties on, but I'm going to try to do it anyway. We'll get that up as high as it can go. Oh, I think this is going to work. We're going to pass it through. Oh yeah, there we go. We got it. Be careful. Don't break anything, but it's gonna, okay, gentle, gentle, the lightest of touches. Yes, it's gonna go through. Hallelujah. I'm gonna pull this. I don't want to put tension here. That will kind of like, I don't want tension on those wires because it'll make them tend to sort of crack or break. But I'm just gonna kind of pull it snug and push this down. And then I also don't like that this is just a little like messy. So actually, let me lift the flight controller back up again. And I'm just going to give the video transmitter a few twists. Again, I don't want to twist it to the point that these wires are under any kind of tension and will like want to break off. Just a little bit of twists to kind of keep that wire neat and coiled. Then we will push this down into place. Next, we're going to mount the video transmitter to the bottom plate. Joshua from the future here. I only just discovered this 3D print in my kit. It was kind of buried in the corner of the kit, and I didn't know it existed. This is how you're supposed to mount your video transmitter. I'm going to show you the right way to do it, and then Joshua in the past did it using double-sided tape, which also is perfectly acceptable. It's going to mount in the back of the quadcopter here. There are 4 M2 screw holes, 1, 2, 3, 4. And you're going to need to find these. These are 4mm M2 screws. They are the smallest screws in your kit. They are in there. And be careful because there are some 5mm screws in your kit. And if you use those, you'll have a problem. The screws are going to go up through the bottom plate, like so. And then they are literally going to screw into these screw holes in the TPU. And the problem is that if you use too long of a screw, it will poke up through the TPU and it will rub on the video transmitter and eventually destroy the video transmitter. Sliding the video transmitter into the mount will be difficult once the mount is installed. So I'm going to suggest you take the mount and you need to hold the video transmitter as I show you here with the antenna connector on the right side. We're going to slide that in. Install the video transmitter in the mount like this. Notice that this side is to the back of the video transmitter. The MMCX is on the left side. The buttons are on the front, and the wires have gotten a little bit compressed, but the mount has some give to it. Just be careful you don't disconnect or damage anything while sliding it in. Now that it is slid in, we will line these screw holes up with the screw holes on the bottom of the plate and install it. When you're putting the screws in, you'll just have to feel a slight increase in tension when it's fully inserted. It will not really seat down because this is just plastic TPU. It's not really a nut or anything like that. Also, it's possible that this TPU eventually will get loose and rip off. And if that does happen, we'll go back to double-sided tape, just like Joshua in the past was going to. Next, we're going to do the camera. And the camera, obviously, we're going to use. This bracket right here is a relic from days gone by when we didn't have frames that could mount cameras. We don't need that at all. And this you should keep. This little joystick right here, is there a wire in here for it? There is. Yeah, we got the wire here in the bottom, this green wire. This right here plugs in via this green wire, which I'm not going to pull out right this second, and lets you modify some of the settings on the camera. You probably are not going to do this. I'm not sure. We'll know by the end of this video. But these don't come with every camera. These work with any camera, any analog camera pretty much. And so if you do get a camera that gives you one of these, you keep it. You just put it in a drawer somewhere and remember where it is so that when you need it, you've got it. The camera's going to connect to the flight controller with this wire harness. It's in the camera bag. And the camera is, every analog camera is always going to have at least these 3 wires: power, ground, and video. And you look, this camera only has those 3 wires. There's the 3 wires, power, ground, and video, and then this extra plug here is for the joystick, and that's pretty standard. You'll see some cameras that have more wires. Sometimes they'll include the joystick plug in one plug, so it'll be a single plug with 5 pins instead of a 3 and a 2. And then occasionally there are a couple extra things that we don't need to talk about in this video Sometimes you'll see a camera with the joystick plug and the video plug in one. So it'll be one plug with 5 pins instead of a 3 and a 2. And then occasionally the camera will have some extra pins that you'll need to look up the user manual for the camera. But generally, most cameras are going to have these 3, and that's what you mostly need to know about to make it work. You will notice that the camera plug has a plug on both ends. Unfortunately, our flight controller doesn't have a plug to plug the camera in. We have to solder it up. So what I'm going to do is I'm just going to, number one, I'm going to double check the length of wire that I need. So the camera is going to go here in the front, and we can see this is more than long enough. I'm just going to cut that. I could even cut it a little shorter. It's going to go, here is the camera header right here. It's going to go there. We don't want it to be too short, but yeah, we could cut that a little less than in half, a little more than in half, and we'll save that wire for some other day when maybe it'll be useful. As far as wiring the camera up, we've got the cam pad here, and that is the video signal from the camera. And then right next to it, we've got ground and 5 volts, and that's going to be power for the camera. Most analog cameras will take 5 volts input. Most of them will also take higher voltages if you need to, but generally you'll power them off the 5-volt regulator. And here is the result of wiring up the camera. And again, I'm just going to give that a few twists to keep it neat. Don't want to over twist it and make it be under tension, but we do want to keep it neat. The next thing I want you to do is take out your antenna, and I want you to plug the antenna into the video transmitter. And the reason for this is that when we go to set up the video transmitter on Betaflight, we're going to need to power it up. And if you power up an analog video transmitter without the antenna installed, you will destroy it. It doesn't happen instantaneously, but it happens faster than you think. And so if like one day you plug a battery in and you go, oh crap, and then you unplug it real quick, you probably got away with it. But if we just plug in the battery and leave the video transmitter on with no antenna, in a few minutes, maybe it'll just be destroyed. So we're going to plug the antenna in, and we do that just by lining it up, and then we just squeeze, and it just clicks into place. Okay. Before we continue with the video, I'd like to remind you that the single best way for you to help make sure that I am able to continue making content like this, which hopefully you value, is to join my Patreon. Patreon is a website where you subscribe to me for as little as $2 a month. That's the minimum amount, just $2 a month. Someone's vacuuming. But join my Patreon, get access to my Discord server, and just feel good about supporting the work that I do here. If you watch my content regularly, then hopefully eventually you'll come to a point where you go, this guy's earned my support. If today is that day, join my Patreon at any level, at any dollar value that you pick. $2, pick $5, pick $10, pick whatever amount you think is fair for the amount of value you get out of my content. There's a link down below where you can click through. And if today's not the day, if you're like, I just want to watch the video, you've probably already skipped ahead. But yeah, keep watching the content. I'll keep making the content, and I hope that day comes. Now that our video transmitter is wired to the flight controller, we need to tell the flight controller the information it needs to be able to talk to the video transmitter. There are many different kinds of video transmitter that the flight controller could be talking to, so simply connecting them together isn't sufficient. And in order to do that, I'm going to need to use Betaflight Configurator. This is the app that we use to configure our flight controller. If you've never downloaded and installed Betaflight Configurator before, I've got a video about how to do that, and I'm going to link it in the video description below. But this is going to be one of those things that is perfectly encapsulated and explained in a separate video, and you may have already done it, so we're not going to go over it here. If you need to, pause the video, go ahead and get Betaflight Configurator installed, get your drivers sorted out if you need to do that, and I'll see you back here when that's done. I'm going to plug USB into the flight controller, and I want you to look here in the upper right where we should see a new serial port appear. Here it is. COM3. Whatever appears there is the flight controller that you just plugged in. With that selected, we're going to hit connect. Now we're going to get some warnings, and I don't want you to worry about those warnings. We're just going to focus on setting up the video transmitter at this time. And the first thing we need to do is go to the ports tab over here on the left, and we need to tell Betaflight which UART our video transmitter is connected on. In our case, we connected the SmartAudio wire to pin VTX1, and that's going to be UART1. So here in the Ports tab, we're going to find the row for UART number 1, and we set up the video transmitter over here in the Peripherals column. We're going to change that from Disabled, and we're going to change that to TBS SmartAudio. And that tells the flight controller that we have a SmartAudio video transmitter connected to UART1. Finally, we're going to hit Save and Reboot. There's one more piece of information we need to put into the flight controller so that it knows how to talk to the video transmitter, and that is referred to as a vtxtable. And the short version of this is that for every video transmitter, you need to find the vtxtable and load it. And in some cases, the vtxtable that you want will be here in the Betaflight Presets tab. If we go to presets and we look for just VTX presets, we can see here are some VTX tables for some common video transmitters. But if I search for stacks, we don't find the Xylos stacks VTX in this preset. I just want to show you this in case in the future you're using a more common video transmitter. That's where you can get the VTX table from. Instead, we're going to go to the product page for the video transmitter, and we're going to cross our fingers that the manufacturer has provided it for us. And sure enough, here we go. Download the Betaflight VTX table for SmartAudio 2.1 integration here. That's probably what we need. And we've got this thing. What I'm going to do is I'm just going to Control-A to select all and right-click Copy this stuff. Then I'm going to go to the Betaflight Video Transmitter tab, and I'm going to choose Load from Clipboard. And when I do that, my screen should change to look like you see here. This is the important part, the stuff you see here, and we're going to hit Save. And then what we can do is we can power up our video transmitter with a battery. Make sure that your antenna is connected or you will destroy your video transmitter. Here we go. When you do that, you should see the LEDs on the video transmitter light up and start blinking. And if we click away from this tab and then come back, we should see Device Ready, Yes. That tells you that the flight controller is talking to the video transmitter. And what we can try to do is we can choose race band. I'm going to suggest that you always use race band because that's what most people are using today, and it'll allow the channels that you're on to be consistent with the channels that they're on. And we can just choose a channel from 1 to 8. My preference is to use race band 8 because that avoids all interference from Wi-Fi devices that might be nearby. If you're somewhere where you know there's no Wi-Fi, you can use any of these. And the most important thing is just to use a channel that nobody else is using who is flying with you. So we'll choose race band 8 and we'll set the power to, let's set it to 25 milliwatts so it doesn't overheat while we're working on it here on the bench, and we'll hit Save. And when we do that, we should see those options update over here. There we go. We just saw them come in over here on the right. So the flight controller is talking to the video transmitter. That's good. Next, we're going to get the camera plates and standoffs. We'll set the standoffs aside and just get the camera plates, and we're going to mount the camera in them. And you're also going to get these silicone, or this one's 3D printed TPU. You're going to get these mounting inserts. And I want you to see that there's two of them. As I said, one is soft silicone and one is a little bit harder TPU. We're going to be working with this one, the harder TPU one. The silicone one is for a different camera. And I want you to also see that the camera plates can only mount on the frame one way. There's a tab here that's going to go in this slot. And then when you insert it, there's going to be a screw hole here that's going to line up there. If you put it in upside down or the left side on the right, they won't line up correctly. So figure that out. And I think the best way to do this is we're going to get these M3 screws. We're going to use just one of them. And I'm going to install one of the camera plates. I just said there's only one way to do it, and if you've got it wrong, it won't go. Yes, the tab wasn't going in. I had the camera plate upside down and on the wrong side. Then what I need to do is I need to find the correct length of screw that is going to mount the camera, but not be so long that it jams into the camera and damages the electronics inside the camera. So what I'm going to do, the camera comes with this hardware here, which I had previously set aside, and I'm just going to go through the screws and try to find the correct length. And I'll start with the longest one, and I will take my little insert and just push the screw through or screw it in and see how far it sticks out. And to me, that looks pretty good. It's sticking out far enough that it looks like I'm going to have a few threads. I've put it in the wrong way around, I believe. It sticks in far enough that it looks like I'm going to have a few threads biting into the camera, but not so far that it's going to jam in and damage something. So I've got the insert, and I've got the screw put into the insert from the indented side to the flat side. Then what I'm going to do is I'm just going to press that into the camera plate, and you need to make sure you press it all the way in or the camera won't fit, and it takes a little bit of force to press it the rest of the way in. So I'm going to press that in, and when I do, it will be basically flush with the camera plate, as you see here. It's not even fully flush yet. Next, I'm going to take the camera and make sure that it's right side up. The wires are at the top, and I'm just going to loosely install it on that screw. And you may be wondering, why don't I just install the camera plates first and then do this? I find it hard to line up the screws, so I find this easier. I don't know. We'll take the second camera plate and we will press this insert in. We will get our screw of the correct length, and we will screw it in from the outside. And then, with a little bit of delicacy, we will line everything up here, and then the tab is in place. Perfect. Tighten that down. Looking good. Everything is looking good. We can just cinch everything all the way down. Next, we'll mount the video transmitter antenna, and in order to do that, we're going to grab 2 of these standoffs, as well as 2 more of those M3 screws, and they are going to mount on the back of the drone in these 2 standoff holes here. Next, we'll grab this 3D print, which comes with the analog kit, and you're going to need to disconnect your antenna from the video transmitter, and you just do that by carefully pinching as close to the MMCX as you can and sort of pull it straight out like that. Don't like lever it, you'll break the MMCX. I'll try to pull it straight out, just give it a little wiggle though. And what you're going to do is just pass that down and press it into this 3D printed holder. If you really wanted to, you could use some adhesive. I would suggest rubber cement or E6000, which is kind of like an industrial version of rubber cement. I would not suggest a rigid or permanent adhesive because you're going to need to change this at some point when it breaks. And then, in order to route the cable, we're going to plug that MMCX back in. And we want to think about how we're routing this. Like, we wouldn't want to just route this like this on the outside of the standoff because that makes it susceptible to damage. So what I think I'm going to do is lay this. Can we lay this like, no, we want this facing out like that. I don't like that sticking up like that. That's not ideal. That's no good because that's going to press up against the top plate and be a problem. Can't really go that way. Huh. Do we need to flip this around? We do. We need to flip the VTX around. Yep, I'm afraid we do. We need to flip the VTX around to the other side. I think this is going to be the way to do it. Oh yeah, that's going to make the most sense. Look how neat that is. Okay, well, you just figure these things out as you go. Press that down on the stand. So that's going to give us a nice, neat routing of that wire. It's not under tension. It's not twisted. It's not stressed. That's perfect. It's laying nice and flat. It's out of the way. That's really good. I suppose if I really wanted to, I could lift this off and pass these wires to the other side of that screw. So now those wires are being sort of pulled to the center like they were before, and that's going to be even better. Here's the result. The coaxial antenna cable is nice and neat, not twisted, not kinked, not sticking out or anything. It's perfect. This wire is nicely pulled to the center and is tucked out of the way here. Everything is inside the drone, and I know that it was a little annoying for you to have to pop your VTX off and flip it around, but I kind of wanted you to see how this decision-making process went, as opposed to like just telling you do it this way without seeing how I arrived at that. I'm just figuring this out as I go, just like you. Well, you're not figuring it out, you're following along, but I'm just figuring this out as I go, and I do this for every build. Video transmitter, camera, installed. That is going to bring us to the end of this video. Head on down to the playlist in the video description or the card that's on screen if you can see the card for the next video in the series. Actually, the next video in the series is going to be either the Walk Snail or the O3 video transmitter. Feel free to watch those if you're interested, but if you just installed the analog one, you could probably skip those. See you there.